Okay, good evening everyone, and welcome to the August meeting of the Ottawa Centre of the Royal Astronomical Society of Canada. I want to thank you all for coming on a Friday of a long weekend. Appreciate that. So we've got a good program for you tonight. We'll have Dave Chisholm's updates on Ottawa skies. I'll give you a quick update on some astronomy news. Rick Wagner will take us through some of the observing programs available through the Society. And then after the break, we'll have our usual programs of the observations, the observing challenges, announcements, etc. So first of all, let's welcome our new members this month: Angela Ahunu, Wendy Good, Anton Petrochenko, Brian Belmont, Vincent Grianti, Ian Thompson, David Dyer, Chris Hodgins, Matt Emborg, and Brad Minot. Welcome. Members in the news. So of late, Gary Boyle and Jesse Rogerson have been doing a tour of all of the major media outlets promoting the opposition of Mars. It's our closest opposition since 2003, I believe. So it's good that they're raising awareness of that. Also, Mike Worth submitted this beautiful image of the moon, and it was selected to be the front cover of the 2019 RASC calendar. Congratulations. All right, so Dave Chisholm couldn't join us today. I believe he's still on vacation in Australia, I believe. So I'll be giving his portion here. So the full moon is August 26th, and today's August 3rd, as you see there on the calendar. The Perseid meteor shower is August 12th and 13th. The Perseids is one of the best meteor showers to observe, often producing up to 60 meteors per hour at its peak. It is produced by the remnants of Comet Swift-Tuttle, which was discovered in 1862. The Perseids are famous for producing a large number of bright meteors, and the shower runs annually from July 17th to August 24th. It peaks this year on the night of August 12th and the morning of August 13th. The thin crescent moon will set early in the evening, leaving dark skies for what should be an excellent show. Best viewing will be from a dark location after midnight, and meteors will radiate from the constellation Perseus, but can appear anywhere in the sky. So make sure you check that one out, and hopefully we get clear skies. Mercury. Look for it low in the eastern sky just before sunrise. Venus is visible all month just after sunset, with the greatest eastern elongation happening on August 17th. Mars is visible all night. Jupiter is visible all evening. Saturn is visible all evening. Uranus is visible all night, as is Neptune. And this is Dave's monthly comic. All right, and next is our 10-minute astronomy news update. Normally Al Scott would give us this one, but he's away. I hope you guys don't get tired of me here hogging the entire first half of the meeting. So as you may have heard, on July 25th, the European Space Agency issued a press release about an interesting discovery made on the planet Mars. The report comes from the ESA's Mars Express, the second oldest spacecraft still operating at Mars. It's best known for the beautiful color stereo images from its high-resolution stereo camera, but these results come from a different instrument. It's called the Mars Advanced Radar for Subsurface and Ionosphere Sounding, or MARSIS for short. Before I explain sort of the discovery, I'll talk a little bit about the instrument. So MARSIS transmits radio waves at Mars using a pair of booms, each of which are 20 meters long. and they extend on the sides of the spacecraft. The radio waves bounce off of Mars, and MARSIS measures the time it takes for the waves to travel there and back. And naturally, Mars detects strong reflections off of the planet's surface. But the long radio waves from the 40-meter antenna can actually penetrate about 5 kilometers into the Martian surface and reflect off of interesting things below the surface, such as subsurface boundaries between different layers that have differing properties. So if you get boundaries between rock and soil, rock and ice, or clean ice and dusty ice. And then the base bedrock can also serve as a reflector. So MARSIS will detect multiple echoes from each radio pulse, and it pulses many times along its ground track, building up a two-dimensional view of the subsurface called a radargram. The bulk of MARSIS's results from Mars Express's 15 years at Mars have detailed the interior structure of the planet's polar layer deposits. Both poles have these deposits, which consist largely of dusty water ice in layers. They have a stripy appearance when viewed from the cameras in orbit, and MARSIS's radar sounding has traced those layers below the surface and mapped the sharp boundaries of the base of the deposits at each pole, sensing the rocky surface of the planet buried beneath kilometers of ice. The MARSIS team first reported on their studies of Planum Australe, the south polar layer deposits, in 2008, noting that MARSIS could detect reflections from as much as 3,000 meters beneath the surface. However, more recently, the MARSIS team picked a region where the surface appearance of the south polar layer deposits were especially bland, to try to study the base deposits in more detail, with the thinking that if the surface of the deposits was less jaggedy or more plain, that you'd be able to get better detail of the things below, because you wouldn't get as many stray reflections of the radar signals. So MARSIS studied this region intensely from May 29th, 2012 to December 27th, 2015, collecting 29 crisscrossing radargrams. In most places, the scientists described the bottommost reflections on the radargrams as weak and diffuse, but in a few places they found it to be crisp and bright, indicating a very strong contrast between the layered deposits and whatever underlies them. In one particular location, about 20 kilometers wide, where many of the radargrams crossed, they kept hitting especially strong and bright reflective boundaries about 1,500 meters beneath the surface. An unusual contained 20-kilometer wide spot of very strong radar contrast suggests an unusual material that is very different from the ice above it or the rock below it. It has consistently been detected over a period of 3 years. So the thinking there is that it could possibly be a long-lived lake, much like the subglacial lakes on Earth. However, a challenge there is that the temperature isn't right for there to be liquid water. The predicted temperature below those glaciers is negative 68 degrees Celsius, or predicted to be negative 68 degrees Celsius. And neither on Earth nor on Mars can water exist as a liquid at such low temperatures, not without help anyway. But help for liquid water may exist there. First of all, you have the pressure of those glaciers, which will lower the melting point of water, and also the presence of salts. Mars has salts of sodium, magnesium, and calcium that, if concentrated enough, can depress the freezing point of water to as low as minus 74 degrees Celsius. Percolates, which are salts discovered by the Phoenix lander and also observed by Curiosity, are especially good at helping water remain liquid at cold temperatures. So it is physically possible that a very salty lake could exist beneath Mars's southern polar cap. So the 200 square kilometer area in study is indicated in the left-hand image. So there's the permanent polar ice cap and the the image of study is just there. That's 200 square kilometers. And then in the middle image, you see the footprints, the radar footprints on the surface of all the passes of the orbiter as it scanned those portions of the Martian surface. So so you can see all the variation in color, and those indicate sort of different levels of reflectivity of the radar signals. And then this area here is the area that they believe may contain water. So that's the area that's reflecting the radar signals quite strongly. So they believe that that's at a depth of about 1.5 kilometers below the deposits. So although there's currently no way to directly confirm that the water is present, this particular orbiter has given us some hope and an indication that this would be an interesting place for future Mars landers to investigate. All right. So up next, we've got Rick Wagner. Take it away. Forward, back, laser.
Okay. Well, good evening. We're going to talk about observing. Anybody done any observing in the past month? It's been pretty much horrid weather. The RASC has a bunch of observing programs to try and encourage people to get out and actually observe. I should mention, Chris Tarrant did all the beautiful artwork on these slides. I sent him some black on white background information. He tiddled them all up, put the graphics on them, so thanks very much, Chris. It makes it look a lot better. So, quite a collection of certificates that you can look at. Tonight, we're going to talk about the beginners ones, explore the universe, and explore the moon. So, first of all, why would you want to do an observing certificate? Well, why does the RASC want to do an observing certificate? To try and get us to go out and observe, to promote the practice of astronomy. For us, well, you could do it for the fame and glory. Generally, this tends to be spot and check, I call it. You go, oh yeah, got it, check, off the list, on to the next target. Not learning anything, you're just running through the checklist as quickly as you can. Gets your name up on the national website. People shake your hand and they bow down to you and stuff. You get accolades and everything. It's marvelous. Good reasons to do an observing certificate. Gives you a list of something to observe. Gets you beyond the same old things. You know, and I've done this many times, as you go out with the telescope and you kind of sit there and you go, oh, there's M13. I haven't looked at M13 in like a week. So, you know, do it again. Do this. So this gives you something to pull you into other areas. Gives you some focus and an organization. I like to spend an hour in the afternoon before I go out observing, look at what targets are going to be up in the sky, sort of, you know, in 2 or 3 hours in the evening. And find out where they are in my star atlas, mark them with little stickies and stuff so that when I'm out there, I can focus all my time on observing. And the other thing it can do for you is help you to explore new fields, areas that you might not have thought you had some interest in. You can try them out and see what you like. So the two beginner certificates, I think it's much more important that we're focusing on skill development. So develop some observing skills. Doing astronomy is difficult. There's a lot of things to learn. Averted vision, how to point your telescope. You know, what's the implications of different eyepieces, different magnification, different fields of view. tracking an object through the sky if you're using like a Dob, for instance, pointing at things. Learning the sky. How do you know where everything is in the sky? You can't use a go-to scope for the beginners certificates. So you have to learn the sky, you learn some of the constellations, the bright stars, so you can find your way around. And what I also like to do and recommend is increase your astronomical knowledge. You can read up on all the objects, you can read up on the specific object that you're looking for, but also the class of objects. So you have a much better idea of the astronomy that's involved. And that's the way to really learn. So the first one, and this is the truest beginner certificate of the pair, Explore the Universe. It attempts to give you a broad overview of most of the areas of observation that amateurs enjoy. There's a list of 110 different observing targets divided into 5 different classes, one of which has 3 subclasses. You can download the list at the RASC.ca website, and it's also available in French if you would prefer. You don't need a telescope. About maybe a quarter of it or something, 20% of it is actually naked eye, looking at constellations and stuff. And I think there's probably not more than 2 or 3 objects on the list that you can't see with a pair of binoculars. And why would you want to do it with binoculars? Well, binoculars are cheaper than a telescope. You may already have a decent pair of binoculars. They have a wider field of view, so it's easier to find things. They have an upright image. You're not dealing with upside down, possibly upside down and mirror reversed like you will with an astronomical telescope. So lots of good reasons. And of course, binoculars, you're always going to be able to use those in your observing. The RASC has written and published an Explore the Universe guide. $18, I think. You can order it from National, or they have a copy in the library here. And it basically gives you some of the background on the different objects and observing techniques and stuff to help get you started. One nice thing is you don't have to be a member to do this one, which I think makes it great if you've got a family member or friends who you think might be interested in. You can try and get them involved, maybe help them along through the program, mentor them. In theory, you could do the whole program in 2 weeks. I'll tell you why, a minimum of 2 weeks. But I think it's much better to spend several months doing it so you have a chance to really absorb the knowledge and stuff. And even better would be to take a whole year and do the complete program rather than the minimum that's actually required. So, the different classes, constellations and their bright stars. They give a list of 24 constellations, each with the brightest 1 or 2 stars and their name. And you have to observe 12 of them. Of course, that's naked eye. Again, constellations are how you find your way around the sky. You're not going to be able to find M13 if you can't find Hercules. Brightest thing in the sky, except for the sun, and pretty much the only thing in the sky that we can see detail on with the naked eye is the moon. So it actually has 3 subclasses. The phases, you have to see 4 out of, well, they list 7 phases, like waxing crescent, first quarter, waxing gibbous, and so forth. You have to see 4 of those. The other option is to plot on 2 or more nights its position in the sky and notice its orbital motion through the sky against the stars. Then the Maria and the basins, you have to see 6 out of 12, so you can easily do this with your naked eye. And then craters, there's a list of 12, you have to see 6 of them. You're going to need binoculars to do those. The solar system, the next object, next range and distance out beyond the moon is the solar system, the planets. Of course, the planets have been wandering about the sky and confusing people for millennia. And so they're very interesting to watch. Actually, just about 2 weeks ago, if you'd gone out, you could have almost completed that whole class of objects. because Mercury, Venus, Jupiter, Saturn, and Mars, so yeah, you could finish it, were all visible in about 10 seconds in the night sky. And then that one also has, it's one of the few ones that has some optional targets. Also solar system-ish things, but like eclipses, comets, artificial satellites, the zodiacal light, a few other things. Many of which, of course, are naked eye again. Out beyond the solar system, we get into what we call deep sky. Clusters of stars, galaxies, clouds of gas, and so forth. They have 24 objects, of which you have to see 12. And trying to think, if a few of them are probably visible naked eye, but mostly you're going to need a pair of binoculars. And there's probably a few of them that you're going to have trouble finding or seeing with binoculars. They're going to be pretty small. You might, you know, you'd probably be better off with a small telescope. But so don't look at those ones. Look at the, you know, the 12 that are larger and easier to see in binoculars if that's what you're using. The other interesting thing, one of the more dramatic things actually for a lot of people, is double stars. Most stars actually are in multiple systems orbiting each other, and some of those pairs of stars you can actually separate on the sky. Some of them, we also have what are called optical doubles, which is just two stars that happen to be in the same line of sight, so they look like they're close together, but in fact they're widely separated in space. And some of those are just spectacularly gorgeous. Albireo is the head of Cygnus the Swan, blue and yellow pair that, is just gorgeous to die for. And for instance, you could read up on why is one of them blue and the other one yellow, and learn all about a whole bunch of astrophysics. Then they have, I think this is heinous, variable stars are entirely optional. Within the program itself, they list two, both of which you could observe with your naked eye. And then they also have a variable star supplement with a list of a dozen or 2 dozen variable stars. And then there's some information on how to, you know, go to the AAVSO and find out about getting charts and so forth. So that's it for Explore the Universe. So how do you do this? Well, you observe at least 50%, and again, I recommend you observe all of them. You're trying to be an astronomer, so don't, you know, why do the least you can get by with? You have to log and document your observations, and actually the application form that they provide is a really nice way to log your observations, because it's got the right number of slots for the requirement, and then it's got a block at the bottom for your observing notes, check marks if you've seen it or not, and so forth. You download the form from rasc.ca, and Ottawa is actually one of the local certification centers. In other words, Chris Tarrant is certified to review your observing log and declare that you've done the observations. Or you can submit your log to the RASC Observing Committee, or you can even go to 2 experienced members of the center and have them certify that they've reviewed your logs and are satisfied that you've done the work. Some resources. Well, you're going to need a star atlas if you want to find your way around the sky. The Bright Star Atlas, the Cambridge Star Atlas are 2 that you might be able to find around, particularly if you go to an astronomy store. I was checking out the Firefly Night Sky Atlas. It's not great. It's also got a map of the moon, which is kind of nice. If you want free stuff off the internet, Tashimi Taki has a Mag 6 atlas, which basically shows the stars that are visible to the naked eye, plus a bunch of deep sky objects. Or there's another one called the Tri-Atlas, Magnitude 9 Atlas, which is a lot more elaborate, shows a lot more stars. and hence it may be a little confusing. The thing I like about these is because they cover wide areas of sky. A lot of the star atlases, if you get more advanced, they show little patches of sky, and so well, here's most of Hercules, but then the rest of it's off on the next chart or over on the next page. And so how do you get the relationships between the various constellations and find your way around? Of course, you can get stuff for your computer. K-Stars, Stellarium, and Carte du Ciel are all hugely capable planetarium programs for your computer. And I don't mention it here, but of course there's the apps for the phone. And the Explore the Universe guide, you can see the cover there. Borrow it from the library here, save your $18. The Observer's Handbook has a lot of information on all these objects, the classes of objects and so forth, stuff on how to observe. I was looking at Terry Dickinson's Night Watch, and that's a great book because it has pages and pages on the astronomy, the objects, using the telescope, what to buy, what not to buy. It's got star charts, it's got all sky charts to help you get the relationship between the various constellations and stuff, so it's really good. And then of course, we've got a whole bunch of experienced observers here, many of whom would be really happy to help you get through the program, show you if you're having problems, help you solve those, how to use your telescope, and especially, of course, at a star party. Bring your scope out. You can do some of the objects there, get coaching from the members. So the other certificate, Explore the Moon. Well, why look at the moon? Well, of course, it's big, it's bright, and it's beautiful. You don't have to travel to dark sky site to be able to see anything. Don't need to use red flashlights. My favorite observing of the moon is I sit out on the front deck with the porch lights on. So I've got my atlas there. Everything is easy to read, easy to see, and the moon in my 8-inch scope is still bright enough that I don't have to worry about it. The moon's easy to find. It does move around a bit, so there will be times of the month when you go outside and it ain't there, and that'll be educational in itself. It's always changing. Of course, the phases of the moon. Its position in the sky changes, but not only that, but the moon apparently wobbles or librates as we go, or as it goes around us, and the orbit tilts and so forth and so on. So there's actually, especially around the limb, the shapes of things actually change. And of course, as the sun rises and gets to noon and then sets on the moon, the lighting on any individual object changes quite dramatically. It's very instructive to observe the moon. Again, there's a whole new set of techniques to try and track the moon, magnification and so forth. And it ruins the dark sky observing about half the time. So, don't just put your telescope away. Get it out and look at the moon. So there's actually 2 different Explore the Moon certificates. One is the binocular one with 40 targets. There's not a whole lot of stuff on the moon that's big enough to see in binoculars easily. The nice thing, of course, is that if you've done Explore the Universe, you've already got a dozen or so of those targets done. The telescope one is more complete, has 94 targets, but they're all quite easy, fairly good sized craters and so forth, that you could easily do in like a 2-inch scope, 50 millimeter refractor or something. And then there's a few extra optional targets if you're interested. It is RASC members only. I call this is a little more hardball. You have to look at all the targets. There's none of this, look at 50% and we'll give you a pass. You have to be a member. The observing list is available on the RASC website, and it includes some maps. They're not very good. They're actually, I think, the same ones that were in the back of the Observer's Handbook. So you'd probably want to have a better lunar atlas. You need 2 weeks to do them, just because that's how long it takes for the Terminator to go across the moon, and most of these objects are much better observed when the terminator is nearby, so you've got the grazing light that gives you the nice shadows and makes the craters all stand out. So in 2 weeks you could do it with good weather. With the weather we've got, you know, maybe a few months or a year. So, yes?
Sorry to interrupt. Because I'm a novice at this, in regards to watching the moon, knowing how bright it is, what's the consensus? Does one use a filter like from binoculars and or a scope?
I don't. I've observed the moon, you know, right from binoculars up to a 12.5 inch, and I don't use a filter. But then I do, you know, I try to be in well lit area, like on the porch or the deck, because it is very bright. But yeah, I don't know, you get used to it. So it's certainly, if you're out observing in a field or something in a dark area, you look through the telescope, you will find that your observing eye is blind, and it does make it hard to find your way around and see things in the dark, you know, the relative darkness once you're not looking through the telescope. But it's not required. Yeah. What's it doing here? Okay, so again, how do we do this? You observe all the targets on either the binocular or the telescope list. Document your observations. One of the things you should ideally do for both of these certificates for ease of submission is to have a separate log specifically for the certificate observations. That way, if you have to send it into the RASC Observing Committee, it's not your whole logbook disappearing. And I assume we all keep logbooks. Download the application form from rasc.ca, fill it out, and submit it to the Observing Committee. Either your log or, again, you can get an affidavit from 2 experienced observers in the center. So, some resources. The Observer's Handbook has about a 4 or 5 page section on observing the moon. It does have the little maps in the back that aren't really very good. Virtual Moon Atlas is online and free, and it's really good. You can get different levels of detail, so it's like a lunar atlas. What's really nice about it is that you can tell at what time you're going to be observing, and it'll show you where the terminator is. Doesn't do all the detailed shadows, but it'll at least show you, you know, sort of what craters are near the terminator and are going to be good to observe at any given time. If you want the ultimate in detail, the Lunar Reconnaissance Orbiter Quick Map site, the link is given there, has virtually infinite detail on the moon. I mean, like, you can get down, you can see the tracks of the lunar rovers and stuff like that, if you want to go that far. Sky and Telescope has a field map of the moon, which is basically, I don't know, maybe sort of 24 inches across, 4 quadrants that will give you all the detail you need to do this certificate. The Firefly Night Sky Atlas also has some decent charts, lunar charts in the back. And one book that I really recommend is The Modern Moon, A Personal View by Charles Wood. Not a fat book, but a huge amount of detail on the latest thinking about how things formed, the mare, the craters, and so forth and so on. So that's something that'll be really educational for you. And so once you've done the Explore the Universe, you can move on to the Messier Certificate. That used to be the beginner certificate. Now it's sort of considered the next step. And of course, the Messier List is 110 objects that were found by Charles Messier back when he was hunting for comets, and he didn't want to confuse them for a comet, so he made a list, a catalog of 110 objects. That's why so many of the observing lists now have 110 objects on them. And they're all fairly bright and relatively easy. A small telescope will get you through there. If, on the other hand, you like the lunar side of things, The Isabel Williamson Lunar Certificate is several hundred objects on the moon. It's much more challenging, and again, a small refractor, 3 or 4 inch refractor or 6-inch reflector is probably adequate to do that. And then there's also, in addition to that, for instance, the Astronomical League in the States has a double star certificate of 110 double stars you can look at. The RASC has a comets list, if that's what turns your crank. That's one of my favorites too. And of course, if you do some of the variable star observing, then you know there's hundreds of them out there, and you can go to the AAVSO and start observing on a regular basis for them. These are the pins that you get when you get the various certificates. So the important thing with the beginner certificates to remember, this is a journey of learning. It's what you take in while you're doing it. It's not a destination. It's not check, 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 done, give me a paper. So, any questions? No? We're all going to rush out and start our certificates. Yes? That's right. I'm not sure how the Messier certificate, I think for a little, or maybe the finest NGC, for a while there they had a go-to and non-go-to versions. I personally don't think, you know, the Messier is advanced enough that you should be using go-to. You know, again, to me it's, you know, learning the sky, learning how to star hop, how to find things. Certainly when you get up into the more advanced lists, go-to is acceptable, and in fact the most advanced list is the Deep Sky Challenge list, where you don't even have to find it. I can find it in my telescope, and then if you can see it, you're considered as having found the object. So they're extremely challenging objects.
Question.
Yeah.
In regards to observing, let's say with the binoculars, can we sort of sign one out from the group here?
Yeah, I'm not sure on the details, but the Lone Library, I believe, has several pairs of binoculars that you could, if you remember, that you could take out.
Is there a minimum age for the certificates?
No, I don't think so.
So for instance, an aunt or an uncle or a father or a mother could take the kids out?
Yes, absolutely. I think that would be ideal. Yes, that'd be great.
All the information that's on the screen, is that available? Someone's trying to take notes, is that anywhere?
I think most of it's probably in the actual observing lists themselves if you download them.
This will be posted on the website anyway, wouldn't it?
Pardon?
Yeah, this will be posted on the website. Talk here.
It may be. I don't know. We could arrange it, make it so.
What makes a good logbook? I've been looking around for one for a while. Amazon, should I buy one on there, or
I think it's a relatively personal thing. If you like to do sketching and stuff, like a lot of people, what I used to do was I printed up a form with like the date, the weather conditions, the seeing, and so forth, and then I had a circle that represented my field of view, so I could sketch things in there, and then you know, just lines at the bottom to make notes on, and then the idea was I would use a page of that for each object. Now, personally, what I do, I actually take a little digital recorder out with me, and I just blather into it about, you know, what it's like and what I see and so forth, and then I just type it all into the computer. I find that's, I mean, some people say, oh, it's way too verbose, but yeah, but that to me encourages me to make all kinds of notes about the things I'm looking at. So, Chris?
I know you have another talk coming on more advanced certificates, but I sense the need for another talk on how to monitor observations.
Yeah, that might be,
Can we sign you up?
All right, sure. Anything else?
Yeah, who's the point of contact for the library and on the binoculars?
Estelle, I don't know if she's here tonight? Yeah? Hmm? No, but yeah, so if you want the ETU guide, you can get it in from, Estelle will have the library open after the meeting. And who runs the Scope Loan Library now?
Aaron Weatherall.
There you go.
Go to our website, you'll get his contact.
Yeah, so, all right?
One more question.
Okay?
If Julia was
Yeah.
we would ask her, isn't there one for young kids as well? I think it's the Astronomical League has the Sky Puppy.
Oh, they may do, yeah.
I thought RASC had one as well.
Not that I'm aware of, no. But, yeah. Yeah, I mean, I don't, I think with some guidance from an adult, I don't think there's any reason a child, even as young as Julia or even younger, couldn't do the, explore the universe.
Greg, if I can, opinion about logbooks.
Yeah,
Some of the logbook that you're mentioning, essentially it's predetermined. You're going to go see these objects first. When you go observing, sometimes you don't always have that long plan. Really, all you need is a bound ribbon, loose leaf folder that pages in it and a pencil, and you just write down whatever comes to mind when you're up there.
yeah.
You need to have a formal.
Well, I mean, with my pages, I didn't necessarily have a formal list to observe before I went out. So I would, every time I look at an object, I would just take a blank page and fill in whatever it was that I was looking at. It does have the disadvantage that it is loose leaf, and a lot of people don't like loose leaf because loose leaves get lost. So, to have a bound book is a much nicer way to go, and that's actually what I used to do before computers became ubiquitous.
Sometimes the observing is more what's in the moment, the environment, what it's like. And when I go back to when I wrote 20, 30, 40 years ago, the extreme, just when I was even talking about the evening environment, the dew,
Yes,
the air going through the trees and so on, that's what brings back the memory.
yes, I agree, and that's why I like my little digital recorder, is because, you can wax eloquent. And as long as you then go back and type it all in, it's all there.
On mine, what I do is I've gone to an art supply store, and you can get bound notebooks that have a blank top half and a lined bottom half. So then what I do is I take a lid from, or a ring from a mason jar, and if I want to do an eyepiece view, I'll draw a quick circle over the upper half.
Right.
Do the eyepiece view there, but then I still have the rest of that blank part at the top if I want to do, drag a line out and do a blow up of a certain area. Just so it gives me a lot of
Yep.
freedom there. There's still lots of room for the notes, and I park notes anywhere in there.
Yep. Yeah, and there's all kinds of different formats of those books. You can get them with lines on one page and blank facing and so forth. Yeah.
Another question now, Greg.
Yeah.
In regards to blog form, because I'm really interested in it, do you actually do it in blog form, like explaining everything in words, or do you have a shorthand or code format?
I think that's up to you. I mean, if you're writing down the same things all the time, another little fuzzy blob, another little, maybe you want a short form, some of it. But I guess the only thing I would worry about then is make sure that you know what the code is. So, in 10 years, you're not looking back at an AFPBL. Okay. Yeah, Chris.
Rick, and another approach on the ETU, if you want to combine two different concepts. Most of the ETU can be recorded with a simple camera, making your introduction to astrophotography. You don't need fancy tracking, just to get the constellations or double stars. That's all you can do easily with a tripod.
I suppose, yeah. I mean, you have to observe them as well. But certainly, yeah, you could document, that could be part of your documentation of what you saw.
So will this be on YouTube or on the website? Is there a camera there?
Yeah, we'll upload the video of this meeting
All right?
All right, thank you, Rick.
Thanks.
All right, up next we've got Chuck O'Dale. He's going to try to stump us here. Just going to advance the slide there.
Okay, thanks. So this is my traditional trivia question. Tonight, it's a fairly difficult question. I've got a shatter cone. If anybody can get the correct answer, it's a shatter cone from the Charlevoix impact crater that Jillian and I found a couple of years ago when we explored it. I'll leave it up here for you to look at during the break. And the guy that wins, or the guy that gets the right answer, wins the shatter cone. So, what's the question? Well, the Earth has, let's say, 1G, right? Well, there's various because, we discover craters by monitoring the different gravity intensities and so on. But for this question, I'll just call it 1. So far, it's easy. How are we doing here? Okay. Now, you can see where this is going. Derek Druin, he won the gold medal at 2.38 meters. Well, in my prime, I don't think I could even get half that. But I was thinking, well, if Derek was on the moon, how high do you think he could jump? Okay, so you have to figure out what's the G-force on the moon. And I was wondering, if we, after Derek had jumped there, if we had a gymnasium on the moon that we could beam him to with 1 atmosphere, no wind, and he jumps again, how high do you think he would go? Well, I'll make it a little bit easier for you. I'm going to take an average human male. This is on the Google. 1.77 is the average height of a male. And on Earth, we'll say he can jump 2 meters. So he's 1.77 meters high, and he can jump 2 meters on the Earth, 1G. We immediately beam him to the moon in the gymnasium. And how high do you think he could jump? 12 meters? Okay, well, here's the rules. Okay, I will take the best answer, but it must be within 1%. If it's better than 1%, I might accept it if I can see your calculations on the right. No guessing, you have to show me your calculations. And if we have a tie, calculate how high Derek can jump. He did 2.38, I think it was. So anyway, I'll leave you with that at the break. Shatter cone for the best answer. Have a look at it, and we'll see you after. Talk to me during the break if you can get the right answer. 1%.
Thank you, Chuck. All right, so we're going to go to break here. We've got door prize tickets. Okay, here we go. So let's get Chuck back up here, and he'll give us the answer to this mystery.
Okay, I had a lot of answers. Some were pretty close. So, here's the problem again. The average male, 1.77 meters, could jump 2 meters on Earth. We beam him to the moon. And how high could he jump? Well, most of you got the fact that the gravity is 6 times, 6.0241 to be exact. So, let's figure out how high he could jump. On the moon, no wind, jump 6.0241 times 2. A lot of people thought that. Not quite. There's this old conundrum. For every complex problem, there is an answer that is clear, simple, and wrong. So, why did we all go the wrong way? Actually, one person came close, I have to say. So we have to take into consideration the center of gravity. And in a typical male, it's around the belly button. So being a typical male, I measured my belly button. and it's 0.5385 of my height.
How deep is the crater?
Yeah. Just for the information, it's an innie. Okay. So, you got a 1.77 meter male with the center of gravity at 0.5385. So basically, we all have, we can jump 2 meters, we can have a head start of 0.9531 meters off the ground. So that's basically the head start we have already. So all we have to do is jump the center of mass over the bar. So we've got a 0.9531 meter head start, and we only have to take the center of mass 1.0469. I'm being exact here, so. Okay, so how high can we jump on the moon? All we have to do is measure the 1.0469 times the gravity on the moon, and he can jump 6.3066 meters. The center of mass jumps, sorry, just to be sure, the center of mass, and one person came very close to that, but he forgot to add the fact that we had the head start. So essentially, if you take the man that can jump 2 meters on the Earth, he can jump, theoretically, 7.2597 meters. That's pretty high, you look at it.
But Chuck, what if he's wearing his suit?
No. Well, if he wore his suit on Earth and jumped 2 meters, same thing on the moon.
But I think if he's still working the angle of refraction and brings it up to knee control meters, I think the first guy was right.
So, unfortunately, my shadow cone is safe. I'm tempted to give it to the person that physically could figure out the center of mass. But to answer for Derek, he could jump over 9 meters. Can you imagine that? Anyway, so I hope you had fun trying to figure it out. And I'll have to say, this question came from Arthur C. Clarke. I was reading one of his back issues, and he's had a whole bunch of short stories, and one of them was this point, that it takes the center of mass over the bar for anybody. So we can figure out how far you can jump on Mars, etc. You have to make sure you add his head start. So actually, keep in mind these physics, because my next trivia question might have something to do with asteroids. So
Thank you, Chuck. All right. So the Royal Astronomical Society is celebrating its 150th anniversary with a campaign to develop and operate a robotic telescope located at a pristine dark sky site with excellent observing conditions. So an opportunity to set up such a telescope came up recently at the Sierra Remote Observatory, nestled on protected land in the Sierra Nevada mountains of California at an elevation of 1,400 meters. This amateur-friendly site has superb 1.0 to 1.2 arc-second seeing, which is far better than we'll ever get here in Ottawa. And quite dark skies at 22 magnitude per arc-second squared. A key advantage of the SRO on-site is on-site technical staff, internet access, power, and the ability to have it monitored 24 hours a day, 7 days a week, and to be able to get assistance with setup, operation, and maintenance without a need to travel to the location. The Society has estimated a startup cost of $75,000 to $150,000, depending on what kind of equipment, etc. And then ongoing monthly cost in the area of $1,500 to $2,500 per month. So they're still trying to work out exactly what the cost model is going to be and what the usage model is going to be. But if you wish to support the project, you can go to rasc.ca/telescope to donate and figure out how else to support the project.
This isn't too close to the fire, is it?
I'm not sure.
Okay.
Yes.
When I donated to RASC last year, it's tax deductible. If it's targeted to the telescope project, would it also be tax deductible?
I assume so. I don't handle the tax deductible stuff for national, but I assume any donations to national, as they are also a charitable organization, they'd be able to issue you a tax receipt. All right. So National has also set up this website here at rascastroimaging.zenfolio.com as a showcase for members that have earned one of the RASC Astro Imaging certificates. So it's kind of along the same lines of the kinds of programs that Rick was talking about, but the RASC has established some for astrophotography, and you can view member images that have been submitted for certificates at that site. All right, observation reports. So if you're on this list, please make your way to the podium. So first up, we have an image from Dave Chisholm from Australia. This is an image that he took with his cell phone from Melbourne, Australia, of that recent eclipse that occurred on the 31st. Yes, the moon is upside down. All right. Thank you, Dave, for submitting that. Oops. Gordon, sorry about that.
I went out to FLO a couple of weeks ago to try and get a grip on my new ZWO camera, and that became an incredibly frustrating experience. So I pulled my DSLR out, put it on my Iopton SkyTracker Pro, and took a couple of images of the Milky Way that was in all its glory. This one is 3 images, 15 minutes total time. Some processing in Photoshop to knock down the glow of Ottawa in the bottom left corner. A little bit of goo, still working on that. And then I took the other end, and that's looking towards I guess that's the west of the site. I was up on the mound looking away from the observatory anyways. And this is 4 images for 20 minutes total time. And that was a ISO 200 with my Sigma 10 to 20 at I think about f3.5. And then finally, I'm working on a mosaic. It's in progress, but I showed it to a couple of people, and they said, well, that's kind of cool. So I have to get rid of the edges to make it pretty. But this is the whole of the Milky Way that I could see from the site that night. Next.
All right, up next we've got Andrew Brown.
Is it going to autoplay when I...
You might need to click it after your name disappears.
Okay. So back in the end of June, I took a trip to Cedar Lake in Algonquin Park with Taras and Eric Lemay. And this is a time lapse, a bit of a different perspective on observing. So in this case, we'll be observing the observers. So please enjoy. Please play. Okay, so that's a little bit of a behind-the-scenes look at the work that we do and kind of activities we're up to produce works of art like this. To date, this is my finest image. I made a pretty substantial milestone this evening. That wasn't at Algonquin Park, mind you, it was Plevna, but before I got into the main sequence of images, which are primarily 5-minute exposures, I was waiting for the moon to set and started a 30-minute exposure, which actually turned out perfectly. So I included that as well. It's a total of 9 5-minute exposures plus the 30-minute. And it has revealed an extensive region of the dust in the area beyond the central reflection nebula and emission nebula of the Trifid Nebula, Messier 20. So this object shouldn't need very much introduction, but it's located in Sagittarius, 5,200 light years away. So it's a cropped view from a camera, but I was confident enough in the quality of my brown stars to take you for a dive up close. There we go. Let's leave that there for a moment. Okay, thank you.
Thank you, Andrew. That was a fantastic image. All right, Taras, you're next.
Comets are beautiful objects. You can see them sweep through the skies pretty fast, and they're usually bright. They have a fiery tail. They have beautiful appearance. Unfortunately, this one is not like that yet. This is still a baby comet. It was discovered last year by the automatic observatory called Pan-STARRS, and the number was given C 2017 S3. It's all of a sudden it brightened up from, if I'm not mistaken, 13th magnitude to something like 10. And it was short after that, when I saw that announced, I took this picture next day, so it was still pretty faint, as you see. However, this comet will be brightening up, and it does as we speak. So around middle of this month, it will be on its closest approach to Earth, while by the end of the month, it will be on the closest approach to the Sun, and it will reach magnitude. Some sources say about 3s, the others say the magnitude will be 6. So definitely might be seen clearly through the binoculars, and I think we might be in for a show. Oh, unfortunately, this doesn't seem to move. It was a motion GIF. I thought that this object will be moving, which is the 4 Vesta asteroid, or the small planet.
It's moving now.
Oh, there you go.
You just had to advance.
Thank you. Oh, that's perfect. Thanks. Yeah, so this was about an hour exposure of this little planet, I guess. It's second largest object in the asteroid belt, and the only largest object larger than that is Ceres. So it's a small planet or big asteroid. For the time when it was taken was, if I'm not mistaken, either in, I think it was, well, camelopardy, no, sorry, more to this. I have that in my notes. Let me check. And this was a sequence of 5 images taken within a span of an hour. In Ophiuchus. So it's still around that area. You can see it as a bright star about 6th magnitude. This is, well, one of the trips to Plema. If you haven't been there, this is a beautiful place for observations. It has everything you need. It's well equipped with steady ground, which is the cement base. It's a helipad actually for landing the helicopters, but the actual helipad is a bit further, while this pad is used for as observation platform. And we used it for the trip when I kind of tried to hunt for Mars. So you see my scope pointing at Mars. What is special about this picture, what I liked the most, was the little bit of fog, which by the beginning of or rather by the end of the night, was collecting on the ground, and it added a little bit this character to the picture. And this is the Mars itself. So as you know, on July 27th, Mars was at its closest approach to Earth. This picture was taken next day, on the 28th, night 28 to 29, and I kept my eye on Mars, trying to make this sequence from May 21st all the way to the closest approach, with different phases, different seeing conditions, different places that this was taken from. For instance, this one was from Arkansas. I went for a few-day trip, just mainly to hunt for the planets. So Mars was one of those on the list. I took some nice pictures of Jupiter from there as well, but perhaps I'll show it next time with a more extended report about the trip. But you can see how within less than 2 months, how much of change was there in the planet's appearance. And what was the most drastic change was this time span over here, where there was a sandstorm on Mars, so that the features which you usually can see and take a picture and map them to the known images of Mars, so I couldn't actually recognize them. This is really, I think, at the peak of the sandstorm. This is about the time when Opportunity stopped to respond, because we expect that it's actually somewhere buried, I guess, under the sand, or maybe just cannot respond because of the sandstorm. So, and yes, if you look at the Mars, even, well, now it's a little bit better, you can see the features, but within the span of this month, all the features were gone. And I tried to make a time lapse with the motion GIF of the Mars rotation. And again, that was from last trip, which was next day after the opposition. Thank you. That's it. Thank you.
Thanks, Saras. All right, Prajesh.
Thank you. All right, so today I'm presenting the Lagoon and the Trifid Nebula. And I really want to give a shout out to Chris here, and thank you so much for letting me submit it so last minute. Just to get an idea of how last minute was, that was less than 15 minutes ago, so thank you so much again for that, Chris. So yeah, just like Andrew submitted, my lagoon's up here. He's already said everything that needs to be said about it. And I've also included lagoon here in this frame. This one was taken with my Nikon D7000 just on a 300mm telephoto lens. And I'm pretty happy with the way it turned out, actually. And I did this with a little bit of a collaborative effort. So I had Taras help me with the polar alignment that night that we were out in Plevna. And I used Andrew's acrylic Batinov mask. And I was really happy with the way it focused using that one rather than the traditional Batinov masks. So I'm really impressed with the way it focused.
Can you explain what that mask was? I saw your note online about that. Can you say what is that mask?
Yes. So a Batinov mask is basically a way to scatter the light, to diffract the light into different diffraction spikes. And it will create like a six spike star. And the way you know that your object is in focus is that as you focus the object, the center spike actually moves right into the crosshairs between the two other spikes. So when you have that perfectly aligned, it ends up that's how you know you have impeccable focus on that object. All right. So traditional Bahtinov masks usually have are usually kind of like a cutout on something plastic, but Andrew actually made one that's purely acrylic, so it lets more light in, and we can show we can actually demonstrate how much brighter it gets using an acrylic Bahtinov mask over a traditional one. And yeah, that's basically about it. The only other thing I want to mention about this picture was that the same night I forgot to take my dark frames while I was in site, so I actually had to go back home, and I kept my camera in the freezer to get the appropriate dark frames needed for this picture. So yeah, thank you.
Thanks, Rajesh. All right, and I've got one here myself. So a couple of months ago, I showed this image of the Leo triplet, and M66 there caught my eye. It was just a cool-looking kind of galaxy. So I shot this with an 80 millimeter refractor with a focal length of, I think it was 400 millimeters. So I decided to point my big scope at M66. It's an 11-inch Celestron Edge HD with a focal length of 2,000 millimeters using a reducer. And I got this image there of M66. So that's 3 hours worth of exposure using 10-minute subframes, processed and stacked in PixInsight. So it's a really cool galaxy. I really enjoy sort of all of the dust lanes and the sort of the brighter H alpha regions on the galaxy. Cool. All right. Thanks. All right, so up next, the observing challenge. So last month we had Albireo. Did anyone get out and observe Albireo? Cool, all right. The intermediate challenge was M20, which we saw a couple images submitted of, so thank you for that. Elephant's Trunk was the advanced challenge, and Gassendi was the lunar challenge. So this month, we've got, for the beginner challenge, M57, which is a planetary nebula in Lyra with an apparent magnitude of 8.8. So you see the constellation Lyra there. There's Vega, a really bright star in the summer sky. And then you got your M57 there. For the intermediate challenge, I'm posing NGC 6572, which is a planetary nebula in Ophiuchus, magnitude 8.1, and it's a pretty tiny one at about 15 arc seconds across. So that one is just right there. All right, for our advanced challenge, posing Palomar 11. It's a globular cluster in Aquila, magnitude 9.8. And the challenge with this one is that it's buried in quite a pretty intense star field, so you actually lose some of the natural brilliance that you'd get in a globular cluster, and it's sort of a little bit hidden. But it's a neat object, so check it out. And for our lunar challenge, the Clavius craterlets. So within the crater Clavius, there are 13 craterlets named Porter, Rutherford, D, L, C, K, N, J, J, A, T, W, X, and Y. So they range in size from the largest at 50 kilometers in diameter to the smallest being 6 kilometers in diameter. And they're best viewed on Lunar's day 8 and 21, and I'll leave that up to you to figure out what calendar day that is. So yeah, check those out. You'll need probably a modestly sized telescope for this, 6-8 inches. So here's the summary. M57 for the beginner challenge, NGC 6572 for the intermediate, Palomar 11 for the advanced, and the Clavius craterlets for the lunar challenge. Be sure to submit your observations for the meeting to me at meetingchair@ottawa.rasc.ca. and to Gordon for inclusion in Astronauts, and to Michael Wilson for inclusion in the website, if you like. All right, the next FLO Star Party, which is for members only. The next one is on August 11th, which is New Moon, and it also happens to coincide with Starfest, so a lot of people will be away for that, but I'm sure there'll still be plenty of people attending this Star Party. For details on our public Star Parties, you can visit ottawa.rasc.ca/content/Star Party. Just go to our website, and there are intuitive links to it there. Our public Star Parties are held in the parking lot of the CARP branch of the Ottawa Library, adjacent to the Diefenbunker. We get the city to turn the lights off. We've recently installed a porta potty there as well, for your comfort. So yeah.
Is there one tomorrow?
We'll see. So it's Diefenbunker is there, CARP Library is there, and usually all the scopes are set up along this section of the parking lot. The next one is tomorrow, weather permitting, of course. We'll probably see an email about that tomorrow, with rain dates of the 17th and 18th of August. Estelle's pick of the month for the Stanmont Library is Neutrino Hunters. Sounds like a fascinating book. I haven't read it, haven't read about it, so I'll leave that to you as well. Club information. So here are the folks that help run the club. Let's give them a hand. If you want to see previous recordings of previous meetings, are available on our website. We had an audience of 82 tonight. Thank you. And thank you all to all the organizers and speakers. Our post-meeting meeting will be held at Grace O'Malley's, so feel free to stop by for a drink or for some fries or whatever, and for some chats. The next meeting will be held on September 7th, Friday, September 7th, 7:30 p.m. here at the museum. And if you choose to join us, you get access to the Ted Bean Loan Library, which we spoke about earlier. There's binoculars and several telescopes, and you'll get some instruction on how to use them and set them up. So go on our site, find the link for the Ted Bean Loan Library, and you can contact our librarian, Darren Wetherall. As a member of the RASC, you would also get access to these publications. Sky News you get, I believe, 4 times a year. The Journal, the Observer's Handbook comes out yearly, and as well as Astronauts, which comes out nearly monthly. All right, and it's time for door prizes. So I'll call out the last 4 numbers.